Hi, and welcome to Prototype. We'll be solving the problem for LeetCode 876, middle of the linked list. This is another problem in the LeetCode 75 study plan. Let's get to it. So given the head of a singly linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node. Pretty self-explanatory, but let's go through the example. So in example 1, we have a linked list with 5 nodes, 1, 2, 3, 4, 5, and it wants us to return the node with the value 3. All right. So what would be the simplest way to accomplish this task? Well, we could travel the whole length of the linked list, saving each reference to the node as we go along, and then returning the middle one when we get to the end. How do we know if we get to the end? When our current pointer becomes null. So let's do that. So let's just have an array to store references. We'll have a current pointer to the current. We initialize that to the head. So while the current is truthy value, so not null, what will we do? What will we be doing? Well, we have to traverse down the linked list. How we do that? We assign cur.next to cur, and then what are we trying to accomplish in each node? Push it into our storage mechanism here, which is an array. Okay, so memo.pushCur. And then once we're at the end, so once cur becomes null, we just have to determine what to return. Well, we want to return the middle one. How do we do that? We can check if the length is even. If it is even, then we return memo.length divided by 2. Otherwise, since in the odd case we want to return the second of the middle nodes, so it will be memo.length divided by 2 minus 0.5. Let's try that. And okay, submit. There we go. Kind of ridiculous that this solution is 92.95% faster. It shouldn't be, but all right, that's LeetCode for you. Now, okay, so is there a better way to do this? Obviously, in the previous way, we would use both linear time because we were going to traverse the whole linked list, and then also use linear space because we were going to save the reference to each node. Can we do better? And the answer is, of course we can. How do we do that? Well, we can use the same logic that we would use to detect a cycle in a linked list by having 2 pointers, one slow pointer that we can initialize to head, and one fast pointer that we would also initialize to head. And while the fast pointer exists, what do we do? Fast travels fast. How does it travel fast? By traveling 2 nodes at once. Slow travels slow by traveling only 1 node at once. And in this case, we'll actually just return slow. So what is the intuition for this? Well, fast travels twice the amount that slow travels. And when fast reaches the end of the linked list, then slow would be in the middle somewhere. Now let's run through example 1. So in the odd case with our current implementation, fast and slow starts at 1, slow becomes 2, fast becomes 3. What happens in the second iteration? We check, does fast still exist? Yes, it does. Slow becomes 3, fast becomes 5. And then we're going to run one more time because fast is not null. So we'll run one more time. Slow becomes 4. Oopsie, we've gone too far. And fast becomes null. We break out and then we return slow, which is 4. So not quite what we want. Let's check the even case. Fast and slow starts at 1, slow becomes 2, fast becomes 3. One more iteration, slow becomes 3, fast becomes 5. One more iteration. Slow becomes 4, fast at 5 becomes, null. We break out of the loop and then we return slow, which is 4. So it is what we want in the even case, but not in the odd case. Now, how can we fix this? Well, we can just simply check if the next of fast exists, and then if it does, then we continue. If not, then we break out early. So we're going to end up breaking out, you could say, one tempo, one iteration earlier. Let's check the odd case. So slow and faster is 1, slow and fast. Slow and fast. Now we check, does fast's next exist? No, it does not. It's null. So we break out of the loop and then we return 3. And slow was on 3. Perfect. That's what we want in the odd case. Let's check the even case. Both start at 1, slow and fast. Slow and fast. Does fast.next exist? Yes, it does. We'll do one more. Slow becomes 4. Fast becomes null. Perfect. So this would work when we're trying to return the second middle node as the question wants. Now, if we wanted to return the first of the middle node instead of the second one, if we wanted to return 3, we could actually also just check one more. So we can just check that next.next exists, and then this would return 3 instead of 4 if that's what we wanted to do. Of course, in this situation, we'd also need to handle the case where the linked list is only 2 nodes, and we could do that separately. But yeah, this is the solution. Let's run it. Okay, it passes the 2 test cases given to us, and submit. And of course, the faster, better solution is slower than the crappy solution. That's LeetCode for you. But okay, so what's going on here? Well, in terms of time complexity, we're still in linear time because we'll be traversing fast. We'll be traversing the length of the linked list, but it will be doing so at n divided by 2, but still linear time ultimately. And in terms of space complexity, well, we're only saving 2 references this time, so constant space. So this is a significantly better solution. It's also less code, which is nice. But yeah, okay, so that is the solution to LeetCode 876, middle of the linked list. Subscribe to see more. We'll be doing the rest of the LeetCode 75 study plan questions in short order. Thank you, and see you next time.